Okay, here we are in the lab, Larry's Electronics Lab. I just started a new YouTube video page dedicated just for the lab, and we're gonna get some really cool content out there. But this is, I got to do some test videos to make sure, prove the process of editing and publishing a video. So this is going to be like an introduction to myself as well as the lab. So let's start with myself. My background, I have a solid background in electronics and embedded systems and C programming and assembly programming, which nobody does anymore. Right after school, I was looking for a job in the late 80s, and so I stumbled on this temporary job at Rogers Corporation in Mesa, Arizona, and it wasn't like electronics oriented, but I needed a job, and it was actually a really good footstep in the door, but I didn't know that at the time. But it paid okay, and I worked as a temp for a while and got hired on permanent. And what we did is we made power bus bars for IBM mainframes, and we basically stamped these copper strips, stamped strips out of this copper with big presses, and to keep them from oxidizing, we nickel plated them, and then there's little tabs where wires plugged on, so they needed to be gold plated for really good conduction. And so my job was to gold plate the tabs. So I was the gold plater of the bus bar tabs. And then that division, I think it kind of went away. Rogers sold out to AdFlex Solutions, and I got moved to the flexible interconnect division, where we made flexible circuit that connected for IBM hard drives, that connected the circuit board to the actual moving head of the disk drive. And it has to be a flexible circuit because the drive's moving back and forth all the time, but it has to be connected electrically. It was the HAL 585 program, I remember that. But then they sold out to AdFlex Solutions, and so I moved on, and I got a job at PyCon Incorporated. Their main office is in Santa Clara, California, but there was a small office in Chandler, Arizona, that I became the technician there. And we did burn-in support for the Pentium chip. Intel was just down the street, so we had to go there a lot. And every Pentium chip had to get burned in. I mean, all computer chips get burned in. They have to go into an oven and get heated up to extreme temperatures, and then run under full electrical load, and they have stimulus programs that run through them and that. So PyCon built the circuit boards that the Pentium chips went into, and you loaded 18 Pentium chips into this board, and then 72 of these boards plugged into an oven, and then you had a whole huge room full of these ovens that just ran 24/7. And so you had to do this to every single Pentium chip for 8 hours, and if it was going to fail, it would fail in that 8 hours, and they did. There was failures. And so I wrote some assembly code that detected which Pentium chip failed in which board and which socket, and gave a binary representation of that on some LEDs. And so I worked there for a while, and they sent me overseas to Penang, Malaysia. I got to see the first Pentium 2 chips come out. They sold $9 million worth of these circuit boards to Intel. And one day Intel calls up the owners and they say, hey, these things don't work, we want our money back. And it's like, we're not that big of a company, and we don't have $9 million laying around. So me and my second tech got on an airplane and flew to Penang, Malaysia to figure out what the hell was going on over there. And it turned out we had our circuit board assembly plant in Santa Clara did a really crappy job. They would put caps on backwards. They had solder shorts, missing solder, and just a lot of solder shorts and backwards caps, basically. And so we sat there for weeks, months, just fixing all these boards and resoldering them and getting them up and running and training the operators to work them right and everything. And so we got big raises because we saved the company $9 million, I guess. And so that was fun. And then later, I moved on to GSS Array Technology in Santa Clara, or San Jose, actually. It's on Santa Teresa Boulevard, or was. I don't think it's there anymore. But so GSS Array Technology, they hired me to be the tech on a line that assembled the very first wireless modem made by Metricom. They called it the Cricket. I don't think it's related to Cricket Wireless, but maybe Cricket Wireless got their idea from them or something. But so we assembled this board for them and developed the process to solder on these two RF shields that go on each side, the board sandwiched between these shields to shield the circuits from interference and to keep interference going out. And but the funny thing is, once we developed this process for them and they seen how we did it, they said, "Oh, we're going to do this ourselves," and they canceled the project and for us. They canceled the line. And so I got moved over to Adept Robotics, and this was a Motorola processor-based robotic system. I didn't really like the way Motorola does their thing, but anyway, it was fun and a lot of experience. I had to fix all the failures off the line, and I only had, because the budget on building these things are real tight, the profit margin, so you can't spend forever fixing a board. So my engineer said I had 15 minutes to look at any single board, and if it isn't fixed in 15 minutes, it goes into the trash. So yeah, I got pretty good at it, and I would go a little bit longer than the 15 minutes sometimes, because I really wanted to figure out what was wrong with these boards sometimes. And a lot of it was just assembly defects, and once in a while a PCB defect, but it was usually just backwards caps, wrong components, wrong values, stuff like that. And then once you get everything working smoothly, then you have time on your hands. So back in those days I smoked cigarettes, so they noticed I was smoking cigarettes a lot, so outside, so they decided to give me another line. And so I ended up with 3 lines in total. I did Interwave Communications, which was a cellular base station, and I believe Interwave is still going on. This was in 1997. And then so I did a little fill-in on the Olicom, which is the Olicom line, which was a digital Ethernet switch. So then I worked there for a while, and then I wanted something different. San Jose rained a lot. I mean, it would rain for like 50 days straight in the winter. Man, I mean, literally 50 days straight, nonstop. And so I'm like, I want to try something different. So I went to Denver. I got a job at Storage Tech. Storage Tech made big drive arrays and tape storage backup systems. Um, and I got hired as the tech for the lead engineer, and we built, it was called the array power supply. It powered the disk arrays. So you had 5 and 12 volt power at very high amperage. Like there was higher amperage than 100 amps, but our power supply I think was around 30 or 40 amps on the 5 volts, I think, which was still, I mean, that's for a small power supply. And so I worked there and helped them build the array power supply, and learned a lot about like UL testing and stuff like that, and a lot of like power. It was power electronics, so I didn't really have a lot of experience in power, so I learned a lot of power and MOSFETs and power factor and all that stuff. And so then I kind of left there, and I just kind of went on my own for a while. I had started a repair shop in Denver for cars, and then I went to later on I went to Hawaii for a while, and then Silverlight. Microsoft came out with Silverlight, and they, because back then Adobe had Flash, the Flash player, so I guess Microsoft wanted to compete. And so they said, oh yeah, Silverlight, it's the greatest thing. It's going to replace Adobe Flash. So I signed up as a developer, and I spent months just hanging out at the beach and traveling around, uh, writing the Silverlight code. I wanted to make a music player for my website, and maybe get it out there for people. And then all of a sudden one day Microsoft just says, hey, Silverlight's discontinued. It's done. Finished. And I'm like, wow, that kind of sucks. So I wasted some time on that. And they had, at that time, Adobe Flash and all those things had security vulnerabilities in them, because when you access data from one domain to another, it's called out of the sandbox. So once you go out of the sandbox, which is your domain, it opens you up to vulnerabilities, and Flash and Silverlight just couldn't recover from that. So those are all deprecated software programs. So then after that, I got into like some maintenance work, for doing maintenance for manufacturing places, because I ended up in Salt Lake, and they don't have a heavy amount of manufacturing there for computers and stuff. So I got doing the maintenance thing, and I actually ended up getting certified in 5 welding processes. And I got a lot of experience with higher voltage, 3-phase 480, and different kind of control systems and automation. And so now I'm doing field. I always avoided field work. I never thought I'd like it. So I accidentally applied for this job that I'm working at now. I didn't know it was a field tech job until I actually got it, and I'm like, oh wow. And so I kind of like it. I drive around in the truck and go to different places, and I see some really cool building management systems, and some pretty, like in hospitals and high rises, and all kinds of business, factories, pharmacies, all kinds of stuff. Everything is computer controlled. So I go around with my laptop and my little tool pouch, and I install stuff and fix stuff and troubleshoot, and it's really cool. So that's my experience with electronics. And so my primary interest through this whole ordeal is embedded systems. And I used to program primarily in assembly language. I loved assembly language. And the only problem with that is it's so low level that it's cumbersome to make sense out of easily. And so they came up with C programming, and that language is much easier to interpret for the human mind to interpret, much faster to develop, takes more space though, which is important with embedded systems, but primarily the movement has forced me into becoming a C programmer. So I primarily program in C now, and then for my Windows apps I use C++, which is basically almost the same. So what we do in Larry's electronics lab is we develop microprocessor based systems, kind of micro-sized devices to control various things. So right now the current project, and my projects aren't like a weekend project or a week or even a month project. I work on these projects for years at a time. And so the one I'm currently working on now is a microprocessor based system where you take boards and you stack on it, and you can stack whatever kind of boards you want on it. The microprocessor communicates through a dual port RAM. So the microprocessor only has to just write to the RAM, and all the commands are read by the daughter boards, the peripherals, and they run based off of the commands that they read from the microcontroller. So my microcontroller is called MainBrain, and we'll get into that eventually. And so the first board for MainBrain is a motion board that runs a brushless DC motor, because my focus in the future is robotics. So I want to build a robot, so we're starting at the very basic lowest level you can get, and we're studying motion and PID loops, and it gets pretty crazy with motion, and there's a lot of mechanical stuff involved. So we primarily, well, almost 100%, we work with surface mount components, and we work with small surface mount components. So back here we have a microscope, and that's the only way that you can solder some of those chip caps and stuff, is with a microscope. So we're going to have soldering videos, we're going to have assembly videos, development, schematic, basic electronics, C programming, USB is a big one, probably some Ethernet stuff. We have a little oven, because some components, SMT components, you just can't access all the pins with the soldering iron by hand, so you have to use solder paste and put it into an SMT infrared oven, and we have a small one for that. We'll do that, and we'll have some soldering instruction, basic machine shop. We got a machine shop, and so we do a lot of our own small parts manufacturing, because prototypes, you can't afford to pay somebody to do it and change it every 10 minutes. It'd be overwhelmingly expensive. So we have a lathe and a mill and welder and hand tools and basic stuff to get us through. And so I guess the next thing is let's take a walk around the lab and just show you what we can do and what we have and what we're going to need and stuff like that. So let's do it. All right, here we are in the lab. So let's start over here. Here's the main computer with the monitor, and this is where all the schematics are done, the circuit boards are designed, all that kind of thing, code written, everything's done over here. Then we have our Denon receiver so we can listen to music, and that provides the mixing, the rudimentary mixing for our sound right now. And then this is my old scope. That measures all the signals that we need to troubleshoot and to evaluate our circuits and whatnot. And then here we have MainBrain. This is MainBrain right here, and it's interfaced through a ribbon cable. Originally I had a header, but the ribbon cable gives you more ability to like unfold the boards from each other and troubleshoot and mess around and move the distance between them and stuff like that. And underneath is the motion board. The motion board is a single axis board right now, and it is controlling this motor, a BLDC motor. This is the test setup. It has an encoder, a motor, and an encoder, and then a drive shaft, and then an adjustment idle bearing. And then we'll get into that later. Then over here we have our surface mount soldering oven. Put the circuit board in there and solder, reflow the solder. And then we have our toolbox, and then we have our local printer. And then over here, this is what, once you have your circuit designed on paper, then you got to prove it. So this is called a prototype. So we do a prototype board. And this is the early days of MainBrain and the motion board prototyping. And then over here we have the microscope where we solder and rework and do whatever, where we like micro work, I guess you could say. And then up here, the best thing I've come up with so far is to use a cell phone as the camera, because it provides superior video that I haven't found anything better than that yet. It was kind of a pain to develop and get going, but it seems to work. And then it shows up over here on the screen. We use Samsung Flow for the PC and the phone to communicate together, and then we can transfer files over to the other computer and edit them, make videos, take pictures, all that. And then here we have our trusty Metcal soldering station. We have our little shot glass. I put alcohol in it, but it's this kind of alcohol for swabbing the boards and cleaning the solder flux. We use solder flux. Got some solder and some solder wick here, and our trusty sponge. Then over here we have the board, but this is getting replaced. We're getting a nice glass one come in on Wednesday. It's just this works great, but it's too bright, and your eyes have a hard time adjusting, so we're going to get rid of that. And then we have an extra Metcal and an extra scope. This scope has a memory problem. We're going to get into fixing that one day. And then we have our speakers for sound. And as far as hand tools, we have different things: crimpers, strippers, calculator, all kinds of little instruments to grab and grip and pluck at things. Screwdrivers, paintbrush to clean dust off the boards and stuff like that. And we have an assortment of calipers for measuring and some Allen wrenches, and so you have to measure temperature sometimes, so we got an infrared temperature reading, and lots of Q-tips to clean. Got some lotion to keep the static down. Then we have our parts. We have assortment of metric screws. We have snap rings. We have potentiometers, more screws. We have solder paste. We have some connectors, and then we have some other kind of connectors and a crimper. We have some spools of wire. We got some more screws hiding down in here. That's about it there. Extra solder, extra flux. We have our heat shrink, heater, and then just some various storage stuff down here. And that's the lab. We'll get into more details later. Here's an upcoming project. We're going to interface MainBrain to this old TV, and we're going to put stuff on the screen and have some fun with that. So we got lots of stuff coming up.